Hello everyone and welcome to this presentation. Today we're gonna discuss project management and this is the third chapter. So basically we're gonna first start by defining a project. So a project is a unique endeavor undertaken to create a temporary product, service or result. So first of all it's unique and it's an endeavor undertaken to create a temporary something that's not gonna stay forever, a product, a service, or a certain result. It is also defined as a series of activities that have a specific objective and in order to and it has a start and an end, so it consumes resources and have a defined start and end dates and are non-repetitive. So there are some main characteristics of a project. First, it has an established objective. So and it introduces, for example, you can introduce a product to the market in 1 year and within a budget of a specific budget and a new product that should meet certain predefined performance specifications. So it has a time limit, a budget limit, and then some performance expectations. And then it should have, as we said, a defined lifespan. So it has a start and an end, with a beginning and an end. And also, it may require across the organization participation. So it could require participation from the marketing department, from the R&D, from financing. So all of these departments can be involved in this project, and it's not necessarily a project of one department. It could be a project for the whole company, and then it involves doing something never been done before. So it's something new, unique, and that's basically the project. And it has cost and performance requirements. So it has very specific requirements for cost and performance. We cannot exceed a specific budget, and we want a specific result at the end. And it also involves uncertainty. And now that is, we have the triple constraint. Now, every project is constrained in different way by its scope. So first, our first constraint is the scope, and then we have also time. So how long should it take to complete the project? And also we have a cost. So what should it cost to complete the project? And what is the project's budget? So we have a budget, we have a time limit, we have a scope limit, which is what's gonna be done as part of the project. So we need to define what are we going to do in this project. So, and it is the project manager's duty to balance these three often competing goals. So the project manager is responsible for um, balancing these three, and a successful project is basically meeting all the three goals and satisfying the uh, project's end user. Yes. So, and that's the triple constraints. Now, okay. So now let's have some examples of project. Now, the first example is development of a new product or service capacity. So, and yeah, so that's one example. And then capacity expansion. Also, so we can expand the capacity um, of our factory, let's say. So expand its capacity of producing items. That's one project that can be done in a certain time and has a limited budget, and also is has some specific requirements. Also, we have the development of a new drug. This is a very complex project and usually takes a lot of time, and sometimes usually it's not met. The the constraints are not satisfied usually because it has like long durations and extreme costs and has chances for failure. So yeah. And then also there is development of a new or modified information. So maybe we have a fintech app that we have, um, and we want to develop a new information or new or modified information for that system. And then there is also construction. So in construction, maybe constructing a new highway, a new roundabout, bridge, tunnel, dams, and etc. So these are all projects. These are all projects, and these are some examples of projects. Maybe maybe in an aircraft um, um, company, they one project is to develop a new technology for their aircrafts that makes it more efficient for using fuel, and that could be a project. So, and then we have project management. So project management is the application of knowledge, tools, techniques, and skills to project activities to meet project requirements. So it's basically applying knowledge, applying techniques, tools, skills, applying to a project to meet the project requirements. Another definition is also the application of knowledge, skills, and tools. Again, that's another definition, and techniques to manage project activities in order to meet our exceeded stakeholders' need and expectations from the project. And then management of projects. There are three main things in managing a project, or three main parts. First, we need to plan. So in management of projects, there's goal setting, which is defining the project, and team organization. So this is the planning part of the management. And there's then the scheduling part of the project management, which relate people, money, and supplies to specific activities and activities to each other, and also timing. Timing is important, and then controlling. We need to control our resources, costs, quality, budget, rolling time, revise plans, and shift resources to meet the time and cost demands. So, planning, scheduling, and controlling. These are the management, three important parts of managing a project. And then there are, again, these are the project management activities, and they go in loop. So we don't do them once and then we stop. No, we do them and then we iterate. We continue doing planning, scheduling, and controlling. We do all of these three things in iteration, and this is the job of a project manager. And so, first, planning. We should establish an objective, define the project. That's our first task, and then we create a work breakdown structure. We have a defined structure for our project, and then we determine the resources and also form organization. So we can um, um, uh, give tasks to specific departments and specific people in the organization, because we need to make sure this project gets done and everyone is doing his job in the project. Because if we don't define who is going to work on this project, then um, nobody's gonna do it. So we need to be able to define the project, and so because everybody's work is nobody's work. So if you don't give people jobs exact specific things they need to do, one will do it. And then we have scheduling. So we have project activities. There's a start and end of each activity, and that's gonna be covered in the um, um, now we're gonna see how are we going to do this, how we are going to schedule. So, and then we have controlling. We need to monitor, compare, revise, action, and do all of these in iteration. And so it's very important. It's iterative and not once only. And then, so and then we have project planning, scheduling, and controlling. So yeah. So first, as you can see, we should plan the project. We should first define the project, and then define the three constraints that we have: the cost, time, and performance. Define how much time do you have, what is the cost, expected cost, and what is the expected performance of this project. And then we need to develop a work breakdown structure of the work, and then I'm gonna show you how are we going to do that now. So we're gonna the work development structure has levels. So level one, level two, level three, and this is how the work is gonna be done in the project, and then we're gonna also identify the teams, the resources, as we said, and all of that. And then we need to schedule. So there is the sequence activities that we are going to use to schedule our project, and then we need to assign people also for specific schedules, and then um, have some deliverables, okay, for scheduling and having the resources. So, and then we have also we need to control during the project. Always we do it iteration, and then like monitor resources, cost, quality. So that's an active job of the project management manager. And then we need to revise and change plans, and that's very important. And then we need to shift resources. Now we do have yeah. So that's basically the same thing. And then how we do each one of these three, there are some specific tools. So for example, for time cost estimation and budgets engineering, the we can use the engineering diagrams, cash flow charts, and material availability details. So you can use the cash flow charts and the engineering diagrams. These are important. And also, some we can document the materials availability. And so and we have also CBM, PERT, which are we're gonna cover them now, which are like sequencing the activities, and we can use also Gantt charts, milestone charts, and cash flow schedules. And then for controlling the project, we need to have, for example, to take care of budgets, delays, or activities report Slack. We gotta define Slack now, and then activities report. So now let's go to talking about the person who's gonna be responsible in the of the project. So we have the role of the project manager. So he's highly visible, responsible for making sure that all necessary activities are finished in order and on time, and that the project comes within budget. So that's our second role. So first we have time, and then we have budget, and then we have quality. Time, budget, quality. These are the three constraints, the three things that need to be monitored by the project management. And then we also need to monitor the people, the resources assigned to the project, um, and make sure that they receive motivation, direction, and also information. It's very important. And then we have the role of the project management again, project manager. He should be highly visible, responsible for making sure that all of the necessary activities are finished in order and on time, and that the project comes in virtually, so it should come on time, yes, and also it meets the budget, it meets the project, the quality goals. So this is the budget. Okay, and the people assigned to the project receive motivation, direction, and information, and they should be so project managers. They should be good coaches and also good communicators because they're gonna deal with people, and they need to be good communicators and also good coaches to teach those people who are working. And also be able to organize activities. Okay, and then we have the work breakdown structure. So there is a structure. First, we start with the project, and then on level two, we have major tasks in the project. So we're gonna now break down this project into smaller and smaller parts, smaller branches. And this is basically the work breakdown structure. Uh, and so we start at level one with the project, the define the project, okay, and then we go to major tasks in the project, for example, recruiting people, and also having a place, okay, choosing the location, the resources, also the supplier. So these are major tasks in the project. And then we have subtasks in the major tasks. So we have tasks under the major tasks. And then fourth, we have activities or work packages to be completed. So these are the specific activities that can be assigned to each and one of the workers in the company. And now this is an example of the work breakdown structure, as you can see. So for example, now this was an example for Microsoft when they wanted to develop a Windows 8 operating system. Okay, so at level 1 we have Windows 8, which is the operating system, and then at level 2 we have then some major tasks in this project. So the project is to develop Windows 8, and then there are some major tasks here, which include designing the software and cost management plan. So managing the cost, and then system testing. So these are major tasks we need to test, um, manage the cost, and then and have a plan for that, and then design the software. So under that, there are also level 3, which are subtasks of the major tasks. So these include developing GUIs, okay, so the interface for the Windows 8, and then ensuring compatibility with earlier versions, okay, and we need to make sure that the application works. And then we have the design cost tracking reports. We need to always track the costs for designing Windows and all of these, and then develop cost schedule interface. Okay, and then we have the module testing for the testing part, and we have defect testing. These are all subtasks in the major task, and then there are specific level 4 work packages. Okay, so we can even break those even further to have, for example, ensure compatibility with earlier versions. So we can ensure that Windows 8 is compatible with Windows 7 and with Windows Vista and also with Windows XP. So you can upgrade from these um, um, previous versions of the Windows. And then we have some techniques. So we need to ensure that all activities are planned for. These are so in scheduling, we need to plan for each and every activity, and also make sure that the order of performance is accounted for. Okay, so not all activities are of the same importance. Some activities are more important to be also done on time and also to be done mostly correctly. And then the activity is time estimates are recorded. Time is very important, and the overall project time should be developed. So and the order is important also. Now, the purpose of project scheduling should show the relationships of each activity to others and to the whole project. So, and this is important so people know, the project managers and the people working below the project manager, they should know, be able to know what are our schedule. So we all be on the same page. That's important. And then we need to identify also the precedence relationship among activities. So when we are done with one activity, we know what are we going to do after that activity. So there is a precedence. It's not random. Okay, and then we also need to set some realistic time and cost. Um, uh, yeah, so cost activities. So it should be realistic. Okay, and then we need to use. This is the controlling. Well, no, sorry. So this is also one reason why we need to make better use of our people, money, material sources, and also all of other resources by identifying critical bottlenecks in the project. So yeah, so it's important. And then there are some project management techniques. So these, what are our project management techniques? I'm gonna show you now. So we have the Gantt charts, and then we have the critical path method, CPM, and then product evaluation and review technique, PERT. Now let's show you. So now this is a simple Gantt chart. So there are no relationship between um, all of the tasks. So the design starts from J up to J, and then prototype from M to A, and etc. And we can't see any relationship really, just list the tasks and when are they going to be done. Now, going to, there's also another Gantt chart, which is basically the same thing. So it's an example, developing a delta jet. So pumping engine, offload, also check, you see, this is a service for a jet. Flight services, maybe this is like uh, okay, so let's say this is like a service for that need to be done usually with our jets. So then we have project controlling. Now this is our third part. So after we schedule, now we need to control the project. So and then controlling is done by close monitoring of resources, costs, quality, and budgets. It's important, and this could be a job of one person to control this. And then also feedback should enable revising the project plan and set resources. So we need to you always get feedback from people and revise the plan accordingly. So and then we have computerized tools that produce extensive reports. So um, computers can be used and in order to produce reports and so. And then there are some project management softwares that are very common in project management. So Microsoft Excel, Microsoft Project, Oracle, Primavera, okay, and then MindView, HP, Project Fast, and Track. These are all popular packages for managing projects. Then we have the project control reports. So these are the reports that we need to document in the project management. So one, the detailed cost breakdown for each task. Okay, so we need to have a detailed breakdown of the costs. And then also we have the labor requirements. How many labor do we need, and what are the costs? Will they be working extra time or no? And then we have cost and our summaries. So what are the costs and what are the timings? And then the raw materials and expenditure forecasts. So yeah, so we're gonna forecast how much material you're gonna need. If you want to expand, how much do we need more? And the variance report. This is important because there are always gonna be variance. And then time analysis report, analyzing time, and then work status report, which is where are we now in terms of our work. And then now let's go to PERT and CPM. Okay, so these are techniques for um, scheduling, used in scheduling. So these are network techniques developed in 1950s. Um, so the CPM was developed by DuPont for chemical plants in 1957 and paired by Bose. Um, um, so in the Navy forces, the U.S. Navy, and it was developed by these people in 1958. So around the same time. So now these two networks techniques consider precedence relationships and interdependencies, and each use a different estimate of an activity time. So they make sure that activities are in a precedence order, and then they use different estimates of activity times, and they are very important here. Now there are 6 steps. So in PERT and CPM. The first step is define the project and prepare the work breakdown structure. The second step is develop relationships among the activities and decide which activities must proceed, and then draw the network connecting all of the activities, assign time and or cost estimates for each activity, and then compute the longest time path through the network, which is called the critical path. And then last, use the network to help plan, schedule, monitor, and control the project. So let's see an example. So there are 6 steps. Define, develop relationships, draw a network connecting all of the activities, assign time, compute the longest path, and then use the network to plan, schedule, and monitor. So we have questions, PRT and CPM that they can answer. So the first question is when the entire project will be completed. Second is what are the critical activities. Third, which are the non-critical activities. And what is the probability that the project will be completed by a specific date. And is the project on schedule, behind schedule, or ahead of schedule? And is the money spent equal to, less than, or greater than the budget? And are there enough resources available to finish the project on time? If the project must be finished in a shorter time, what is the way to accomplish this at the least cost? So we have an example. So Milwaukee paper manufacturers activities and predecessors. Okay. So we have the activity one is to build internal components. So we have these lists of activities which are modify roof and floor, construct collection stack, pour concrete and install, frame build high temperature, burner install pollution control, and these are all tasks. And there are some immediate predecessors. Okay, there are some immediate predecessors. Okay, and also okay. So then we have the network. So we have this is our example. Okay, so these are our tasks, and there are some predecessors. Okay, tasks that cannot be completed before the predecessor be completed. So and this is the network for Milwaukee paper. So the arrows show the precedence relationships. Okay, so we need to start, go to A and then B, and then after A we need to complete C and D, okay, in order to proceed to our next activities and so on. So there is a network. That's why they call the network. So in order to determine the project schedule, we need to perform a critical path analysis. So the critical path analysis is the longest path through the network. There is a longest path through our network, and then it's also the shortest time in which the project can be completed. If we exceed this time, the critical path time, then we are not being on time and we are drafting from the time. So, and then and any delay in critical path activities will delay the project overall. And critical path activities have no start time. And so we need to determine the project schedule. We have time estimates. Okay, so first activity is to build internal components. These are just examples. Okay, and each activity has its own time in weeks. Okay, and then if we're gonna do that, say, okay, so let's talk about these. So there is what you call earliest start (ES), which is the earliest time at which an activity can start, and then we have earliest finish. So it's the earliest time at which an activity can finish. Latest start, the latest time at which an activity can start, and then the latest finish, the latest time by which an activity have to be finished. And now, if you can see, now this is the activity format that we are going to use. So the earliest start is the earliest time we can start doing an activity. The latest start is the latest time we can start an activity. Otherwise, if we exceed this time, we are going to be delayed. We're gonna delay the project. And then earliest finish is the earliest time we can finish. If we finish before that, we're gonna be um, um, on time, and even better, we're gonna be yeah, so, and also we have latest finish, and the latest finish is the latest time we can finish, and we cannot exceed this time. And now the forward pass begins at starting every and work forward. So there is a rule, area start time rule. If an activity has only a single immediate predecessor, its earliest start equals to its earliest finish of the predecessor. And if an activity has multiple immediate predecessors, its earliest start is the maximum of all of the earliest finishes. Now, let's show you what does this mean. So early start equals the max of all immediate predecessors. We have also the forward pass, so begins at starting event and work forward. Earliest finish time rule. And then there is another rule. So the earliest finish time of an activity is the sum of this earliest start, ES, and its activity time. So EF equals ES plus activity time. Now let's show you this in practice. So have here ES, EF network. So okay. So now basically what we are having here, let's say that the time here is in weeks, okay? And the early start of a specific task is gonna be 0, so it's gonna be at the beginning, at the start of our activity. So this is the early start. And then the activity will take 2 weeks. It's called activity A, okay? It has a specific task that we need to accomplish. And then basically the earliest finish we can finish is just the time it takes to accomplish activity A plus the time at which we start. So we started at week 0, then we add also on top of 0, we add the time needed to finish this activity, which is basically 2. So 0 plus 2 is 2. And that's basically how we usually um, find or create this network. So now let's show you another example now. So we did this. So we started at week 0, and then we went to, from week 0, we added 2, which is the time required for activity A. Then now, from here, let's say activity B has no predecessor, okay, and it starts immediately at the start of the project. So we're gonna do activity A and activity B at the same time. Okay, we're gonna start them together. So and then the earliest start of activity B is gonna be at 0, and which is the beginning of our project. And the time required for B to finish B is gonna take 3 weeks. Let's say this is for our Microsoft Windows example. This is designing or maybe making the yeah. So let's say designing the interface. So for designing the interface, it would take, for example, 3 weeks. Of course, not 3 weeks, but let's say 3 weeks or 3 months. Can be. So here we are talking about weeks. So basically, the earliest finish, the time in which we can finish the earliest, is just 0 plus the time it takes to accomplish B, which is 3. So there is the earliest start, earliest finish network for my work paper, as you can see. And there's also now the other, basically the other rule for this. So this is the network basically. So we add the numbers here. So here we're gonna have 2 in the green, and then 2 is gonna move here. It's gonna move to the other upcoming activity, and then it's gonna be the time for to accomplish this is 2, and then 2 plus 2 is gonna be 4. Okay, and then 4 is gonna move both here and here, okay? Then we're gonna add 4 to 4, so it's gonna be 8 here. And then 4 plus 3 is gonna be 7. Okay, so here we have 8, here we have 7. Now I wish I could write here. But unfortunately, I'm not using my iPad to present this. So let's just imagine. Okay, you should be able to so 0 plus 3 is just 3 here, and then 3, so it takes 4 weeks to finish activity D, so 3 plus 4 is gonna be just 7, and then 7 is gonna move on. Okay, so here we have 8. Why do you think here we have 8 and not 7? So this is basically because we do have here 8, and if we have 2 tasks, we have a task that has multiple predecessors. Okay, this is the rule that we have. We're gonna take the value for the highest predecessor. So here we have 8. We have here 8. We have here 7. So we're gonna take 8, which is the highest of the two. Okay, and then the 8 we're gonna add it to 5 is gonna give us 13. And then here we do have 7, and here we have 13. So which one is gonna move here? The 13 is gonna move here because this is the highest. And then we add 13 to 2, which is 15, which is the earliest finish we can finish is after 15 weeks. We can finish the whole project. And that's basically how we do it. Now there is another rule, which is the backward pass. So it begins with the last event and works backward. So it begins from here, from this last event H, and it works backward. So it's the opposite of what we are doing. Okay, and also here make sure that we have we have here 2, we have here 3, but we move the 3, we add the 3 here because it is the largest of the two. And then we have the backward pass, which begins with the last event and works backward. So, and we have the latest finish time rule. So if an activity is an immediate predecessor for just a single activity, its last finish equals to the last start of the activity that immediately follows it. Let's show you this. Also we have latest start time rule. If an activity is difference of the last finish time and its activity time. So basically, now we have this field. Now we have here 15. We gotta take the 15 here and put it basically down, which is the latest finish we can finish. We cannot finish any later than that. Okay, we can finish only after 15 weeks. Now, we're gonna subtract now. So now, in order to get the latest start, we're gonna subtract the time it takes to accomplish event 2H. So it's gonna be here 13. Now 13 is gonna move here. It's gonna be 13 and 13. Okay, now we're gonna subtract, so we're gonna have 10. We're gonna have 8 here. Now 8 is gonna move here and here. Now here we said 13 minus 3 is gonna be 10, and then 10 is gonna move here, it's gonna be 10, and then it's gonna move to become. Now here we have let's see. Okay, so as you can see, 30 moved here and it became 10. Okay, we always subtract, so we are taking the latest finish and latest start. So now this is the filled one, and then here it becomes 8. Now we're gonna take 8 here and 8 here. Okay, then we're gonna subtract, we're gonna get 4. Now we have here 10, we have 4. Now which one do we choose for here for this activity? We're gonna choose for the latest. Now when we were going forward, we were choosing the highest. Now when we go backward, we're gonna choose the smallest. So we're gonna take 4. Okay, so 4, and then 2, and here 4, 4, and then and here we are faced with the same issue. Do we take 2 or 4? We're gonna take 2 because it's the smallest for activity A. And here 4, and then it goes here. We have 0, 1. We're gonna take 0 and then 0. That's basically how we fill up this whole activity task. We need to have the network and then have the activities and the time to complete each activity, and then fill up this Malwaka paper. And then there is something also what we call the slack time, which is the time which is the latest finish, the latest start minus the earliest start. So it is the latest start we can start with minus the earliest start we can start with, which is for our example here let's take this activity D. So the latest start is 8, and the early start, the latest start is 4, and the early start is 3, which is 1. Which also, so the slack for activity D is 1. But also we can find it from the latest finish minus the latest, the earliest finish, which is 8 minus 7, which is 1. Also, so we have two ways to find this. So here the slack is 1 minus 0, um, latest start minus earliest start, so 1, and then latest finish minus earliest finish, which is 1, so the slack for B is 1, and here J, the slack here is 0, so we cannot delay this. Here we can delay it for 1 week, this one can delay it for 1 week, but any event that have a slack of 0, we cannot delay it. So it's very important to be on time for this. So there are two formulas for this. Either latest finish minus earliest finish or latest finish minus earliest finish. And also we can compute the slack time here. Computing the slack time, latest finish, slacks on critical path, earliest finish. So, and what is the critical path? We didn't discuss the critical path. The critical path is basically the path in which the slack is 0. We cannot delay it. So if you go from here, this is the slack is 0, and here the slack is 0, and the slack is 0 here, the slack is 0 here, the slack is 0. So the critical path here is A, C, E, G, H. We cannot delay this path. So this path is the critical path and cannot be delayed, should be all the time. The other activities can be maybe delayed or arranged if we need to, but the critical path cannot be, or otherwise we'll delay the project. So that's basically the critical path. And here, as you can see, some activities are on critical path, others are not. So, and now we compute the slack time. My Luca paper, this is students, okay. And that's all. Thank you for watching, and I hope you benefited from this short presentation.